Okay, this video is called Proof That God Made Us to Eat Plants. And I'm going to say some things you've heard before, Dr. McDougall or myself talk about, but I'm also going to say some stuff you have not heard before. I can guarantee you that. So we'll just start out with a classic painting here of God designing the world, the Atlas of Ancient Days by William Blake, 1824. Tiger, tiger, burning bright. All right, so the next one here is God designing the creatures of the world, and it's thought that life began in the ocean. And one of the key points about the ocean, there's salt water. Another key point is when you have a cell, like you form a round sphere that's going to be alive, if it's just salt water in there, it has to be equally osmotic as the surrounding salt water. So in order to have anything else in there than salt, you have to pump out the salt so you can have other particles in there osmotically. So getting the sodium out of the center of the cell is essential for life. Okay, that's going to come back, and that's real important. Okay, and it'll make more sense in a moment, but this is all going to make sense. But what I'm trying to tell you is you have to get the sodium out. That's why cells have low sodium in themselves centrally. Okay, now here's a little bit about how a cell works. This is 1/3 of the energy of a typical cell. In a neuron, this is 2/3 of the energy. You'll have this potassium-sodium ATP pump. So it's going to bring in 2 positive charges of potassium, 2 coming in, and more importantly, 3 going out. So 3 going out, that means there's a net electrical charge exiting the cell. The current is carried by sodium ions, all right? So that's going to make a negative charge inside the cell because you're pumping out more of the positive ions than what you're bringing in. That's going to create an electrical gradient attracting positive charges to want to come into the cell towards that electric charge. That's that electrical gradient. You're going to have 10 times more sodium outside the cell than inside the cell. That's a chemical concentration gradient. So the sodium really wants to come in. I said this before, that sodium is like the angry poor wants to bust into the city. The city is the cell. Okay? The potassium is like the good middle class trying to maintain the function of the cell. Magnesium is also sort of the good middle class. Magnesium also, you would even call it the mellow ion, all right? Because it helps to block calcium from coming into the cell through a separate receptor, the NMDA receptor. We're not going to get into that right now. I've even heard magnesium cleverly described as a calcium escort, saying, okay, calcium, you can come in the cell, do what you got to do, but I'm going to help make sure you get pumped out as soon as you're done doing what you want to do. Calcium is like the bossy, unreasonable aristocrat that just comes in. It's like flicking on the light switch. It activates the cell to do whatever it does. Okay? But the important thing is, in order to maintain life on Earth, you've got to get that sodium out of the cell. Most of the cations in a cell are sodium and potassium, meaning positively charged ion. It's about 98% of the positively charged ions. And there always has to be a constant amount of them. Otherwise, if the cell had too many ions coming in, it would become hyperosmotic. Water would come in, the cell would swell and burst. So it's always going to be that way. And what that means is it's a fixed sum game. If you increase your dietary sodium, you're going to decrease your body's content of potassium. There's no way around that. Okay, so here's what I meant by it's a constant. The total amount of potassium and sodium inside a cell are constant for osmotic reasons. So they're always going to be that way. And if you eat excessive dietary sodium, you're going to urinate out potassium, and you're going to have more sodium inside your cells, and you're going to weaken that electrochemical gradient, which is the pumping power of the cell. The sodium-potassium pump is like an electrical generator. Okay, let me just show you that again. This is an electrical generator. This sodium-potassium pump. This is the current, the positive charges of sodium coming out. This separates the barrier. So it's like an electrical battery. So God made an electrical battery in the plasma membrane of the cell. And you need that because then you can run that, you can couple that to pumping calcium out of the cell. The calcium gradient is like 10,000 times, water washing over the limestone, okay? 10,000 times higher outside the cell than inside the cell. So you had to get calcium out of the cell too. The concentration inside the cell is very low, literally 10,000 to 15,000 times lower than it is outside the cell. This is a Naka exchanger. Natrium is Latin for sodium, calcium. Okay, NCX, it's abbreviation. You allow sodium to come into the cell of its own accord, and that can be coupled to pumping out calcium. It's like a water wheel. You can also think of it as like a revolving door in like a big hotel or big, building where they've got those revolving doors, and calcium coming in permits sodium to pump out. You can pump out 5,000 sodium ions per second doing it with this pump, the Naka exchanger. Okay, we talked about it has to be constant. So you can't get around this zero-sum game. The more sodium you eat, the more potassium you lose. Okay? But I'm getting to design here in a moment, and I think you're going to find this quite interesting. I'm going to tell you, I guarantee you things you never heard before. Okay, so here's God designing the animals on the earth. Okay. Here's the creation of man, with Adam creating the image of God, an essential concept for mankind getting along with each other and having respect for most individuals who are weak and can't really defend themselves. So you got to respect the individual, otherwise they don't get treated so nice. And that's why the only thing that can save healthcare is to have Christian ethics, that man is created in the image of God and we will respect him and forget about the money. We'll do what the right thing is. Okay, and this comes from Genesis 1:29, that God said, "I put every plant on earth that shall be food for you." All right. Now, the next thing is go in the mirror and take a look at your teeth. And what you will see is that they are flat. Okay? Flat for grinding plant foods. Our jaw can go side to side so we can grind plant foods. That's characteristic of a plant eater. A true carnivore, like a cat, has a fixed forward jaw, so it has a much stronger bite. Okay, now if you're walking down a path, the purpose of a brain is to walk down a path in a forest, a prairie, or a jungle and survive, okay? If you come upon a dead deer, the carcass of a deer, flies buzzing around on it, do you want to get down on your knees and take a bite out of it? No, it's disgusting. And your teeth, you can't even pierce it, okay? We're not made to do that. We're just not. We, intrinsically, we tend to feel a little bit sorry for the poor deer, okay? Unless we're starving, okay? Then we might make exceptions. But in general, we don't want that, okay? Now take a look at the next picture here. If you see a bowl of fruit, you immediately salivate, okay? You like that. You're attracted to that. You move towards that. And it looks wonderful, okay? And I think the reason we have color vision is so we can see when fruits are ripe. And the different colors are the different antioxidants of the fruits. It's like a happy day when you see that on the table. There's only one thing more attractive than a bowl full of fruits. And that's a bowl full of fruits carried by a woman, okay? That's what we like. We are programmed to like that. We're born to like that. There's few things a man likes more in the world than a woman walking towards him, offering him food, okay? We love that, okay? We'll support you for that. Cook for us, be nice to us. You don't have to work. Just take care of us. We'll take care of you. All right, now just to show you some numbers, a little reality check. This is what is called the K factor, the ratio of potassium to sodium. In a banana, you've got 450 times more potassium than sodium. In a watermelon, 270 times more potassium than sodium. In an orange, 250 times. Strawberry, 170 times. Raspberries, 150 times. Steel-cut oats, 160. So I think we're made to eat fruits and starches, okay? I know Dr. McDougall says only starches, and I agree starches should be the main staple of our diet, but I'm also saying fruits come to us naturally, and fruits are really good foods. The modern stuff's a little bit more engineered to be a little sweeter, but we are good at eating fruits. And a lot of people eat tons and tons of fruits, and they're very healthy, and they can even compete in sports and do very well in endurance and whatnot. Starches also have a very high K factor. So with fruits, it's quite often over 100 times more potassium than sodium, which is going to have major consequences for the physiology of your body. The starches routinely have K factors in the region of 40 to 60. So let's say an average of about 50. Like here's a potato, has a K factor of 40. All right, white rice, K factor of 60. Brown rice, K factor of 50. Some green beans, K factor of 40. Peas, K factor of 50. Lentils, 50. Okay, so just to give you perspective, sweet potatoes, now you're getting a little lower, around 14, which still works quite well. Our ancestors probably ate about 15 to 20 K factor, okay? You look at veggies. Veggies are K factors of around 5 to 15. Okay, here's everything in green is a veggie K factor. Now you look at animal foods. If you're looking at ground beef, it's more like a K factor of 4, which is bad but not super bad. You get to more processed foods like soy burgers, K factor of 1.6, Cheerios 1.2. It gets worse and worse. Look at Special K, which claims to be a healthy cereal. It has a K factor of 0.06. That's terrible. All right, but do you see the pattern? The best foods have really high K factors, okay? That's an important point. So what does that mean? That means our entire body is designed for a high potassium intake and a low sodium intake. So what I just said, our ancestors ate a K factors of 15 to 20, and all large healthy populations are starch-based, but modern humans in Western countries are typically eating 2.5 times more sodium than potassium. K factors of 0.4, less than 1. That's terrible, okay? Okay, so the reason I showed you all that was to make a point. How can your body handle that? Why do you not just die? Okay, because it's such a steep ratio of potassium more than sodium. And the reason is because your kidney is made to excrete potassium. Why would you have a kidney designed to excrete potassium and save sodium if you weren't designed to eat the foods that were high in potassium? Does that make sense? What I'm trying to say is you've already heard about the teeth being designed to eat plants. You've heard about the long intestinal tract designed to eat plants. You heard about our lack of vitamin C because we're designed to eat plants, so there's tons of vitamin C in there. But I bet you didn't know that your kidney is designed to excrete potassium and save sodium. And that's also consistent with the idea that we're designed to eat plants in a very high potassium diet. We can totally handle these 100 times more potassium than sodium is easy for us to handle. 200 times, 300 times, 400 times, 500 times. Easy. Why is that? Because we're designed to eat that way. Okay. All right, so getting back to it. This electrical generator, this is the only thing that pumps potassium, the only thing that pumps sodium out is the sodium potassium ATP pump. It has to be done with energy, ATP from the mitochondria, because you're pumping against a gradient. Okay, everything else couples itself to the electrical power of bringing sodium back into the cell that then can pump other things. And that's how cells work. And also, you got to get that calcium out of the cell, because calcium getting higher in the cell activates the cell to do whatever that cell does. That's going to become important. I'm going to show you in a second the relevance of that. Okay, we talked about the constants. These two things are constant. So you can't win the game. You either eat the high potassium diet or you mess up your cellular gradients. And that means you cause a dysfunction in all your cells. Everybody talks about sodium causing hypertension. But what I want to point out in this lecture is it causes a ton of other things that you don't want. It activates your brain cells. By increasing the amount of calcium in your brain cells, they're more predisposed to firing action potentials. They're releasing their neurotransmitter. So they increase your risk of being a little anxious, a little insomnia, a little bit of impulsive behavior. You ever wonder why paleo keto carbs are such jerks? I could have called this video, "Why are paleo keto carbs such jerks?" Okay? Because they're impulsive. They're sort of agitated. And they know their claims are bogus. And so, like Cicero had said, when you've run out of arguments, just abuse the plaintiff. Okay, if you know that your argument is bogus, all you can do is try to insult and slander the other person. And that's what paleo keto carnivores do. So increased cytoplasmic calcium causes vascular smooth muscle to contract, to narrow the artery diameter, cause high blood pressure, causes neurons to release their neurotransmitter, causes pancreas beta cells to release their insulin. It makes the cell typically do whatever that cell is designed to primarily do. Okay, so we talked about you got to have a minimum K factor of 5, more cells. I'd say you should try to keep it higher than that, probably at least 10. Magnesium in the center of plants holds on to the 2 APs. Tons and tons of reactions in our body are dependent on ATP. ATP is dependent on magnesium. Almost the vast majority of Americans are deficient in magnesium because they don't eat plants. Magnesium comes from the center of chlorophyll. They're deficient in potassium because they don't eat plants. They're deficient in fiber because they don't eat plants. Okay? All the good stuff comes from plants. The only thing we're missing is the B12, and that used to be available from plants because it's from the bacteria. So here's magnesium in the center of chlorophyll. So you eat your plants, you get all these things that you need. When you got chronic hypertension, you'll start causing hypertrophy of the vascular smooth muscles. That's bad. That could decrease your oxygen glucose delivery. It makes your cell less responsive, able to dilate and constrict in proportion to demand. Okay, you'll also get glycation in your capillary basement membrane if you're becoming pre-diabetic and diabetic, and you'll even start laying down collagen in here. So the longer a person is hypertensive, the longer they're diabetic, the more they start getting irreversible damage to the arterial wall. Actually, the smooth muscle hypertrophy can be reversed, but it takes a lot longer. This is also why somebody who's been chronically hypertensive for decades, it's going to be harder for them to reverse it. Somebody who's only been briefly hypertensive for 1 year, they're going to probably reverse it very easily by switching to a plant-based diet, high in potassium, low in fat, okay? But somebody who's been hypertensive for 30, 40 years, they've got a lot of irreversible damage to their wall. They've lost the Windkessel effect in their ascending thoracic aorta, and they've got stiff, inelastic arteries elsewhere, so it's going to be much harder and slower for them to reverse it. And what this picture also shows is you got a lot of good oxygen delivery from a normal capillary. These are the red blood cells traveling through the capillary. These are the endothelial cells, spindle-shaped, orientated along the long axis of the vessel. The blue circles are the oxygen passing through the capillary basement membrane, and then they go to the neuron, the brain cell in this case. But you get a thick capillary basement membrane and a lot of vascular smooth muscle hypertrophy due to chronic hypertension and diabetes. You're not going to deliver oxygen to the tissue as well, and it's going to be much worse in the setting of a high-fat diet and a high sodium meal and a caffeinated meal. Now this guy, Richard Moore, MD, PhD, he started researching plasma membrane ion pumps with regard to especially sodium and potassium back in the 1950s. And he's a brilliant guy, and this was his legacy book, High Blood Pressure Solutions, the best book ever written on blood pressure. All medical students should read this book because you will have a dramatically improved understanding of plasma membrane function when you read this book. Okay, it's a fantastic book. It's one of the all-time great medical books ever written. Okay, and then what I've done in this talk is just taken his ideas and gone a little farther with them. Okay, so the high salt diet also increases calcium concentration in the cytoplasm of your neuron, so it increases neuronal excitability. The higher the calcium, the more the neuron starts firing and doing things that neurons do. So high salt diet increases neuronal excitability. That's a big deal. Okay. That's part of why paleo keto carnivores are such jerks, because they often eat high salt diets, and people eat processed foods and sad diet. They'll have less impulse control. I noticed myself, I think I mellowed out when I became a vegetarian. Part of that's, getting older, becoming more mature, but it's also, I think, the change in diet. It's well known that vegans tend to have a more positive mood, and they're happier, they're more mellow, they're more calm. Magnesium is the mellow ion, and it mellows you out because it blocks the NMDA receptor, the calcium channel for glutamate. Dietary salt intake exaggerates sympathetic reflexes. Okay, so you get increased sympathetic fight or flight impulsiveness from a high dietary sodium. It has an effect on mood. And that's relevant too, because you see these kids that, you give them candy and they're all crazy, and people say, oh, there's that sugar making them crazy. Well, it's more than the sugar. Like the Feingold diet, it's also the food preservatives, the food coloration dyes. They make kids hyperactive, all right? And they can cause other problems with brain cells because they're toxic. They're neurotoxins, not to mention the atrazines, a mitochondrial inhibitor, an estrogenic chemical. The glyphosate's excitotoxin, increases excitability in the NMDA receptor, the glutamate receptor, calcium channel. Okay, so they are toxic. The high fructose corn syrup often contains mercury. That's also neurotoxic. Okay, so the reason the kids, hyper is not just because of sugar. It's because of neurotoxicity of this junk food. Okay, these are just some papers we've gone through before. Donaldson paper in Kenya, 1929, blood pressure in the African native, and the point was that 1,800 consecutive adult admissions to a hospital in Kenya, and not a single patient was hypertensive, whereas it'd probably be about 80% of black adults will be hypertensive if you just check their blood pressures when admitted to a hospital in a Western country. So the point is, there's nothing genetic about it. They ate a plant-based diet in Kenya, no hypertension. In the Western world, they tend to eat way too much processed food, typically the SAD diet, standard American diet, so they got a lot of hypertension. And if they ate this way, they wouldn't get it. And it's the main risk factor for atherosclerosis, for stroke, and one of the main risk factors for kidney failure. And so if they learn that, they will be so much more healthier. If everybody learned that, be so much more healthier. Yanomamo, where they eat the primarily plant-based diet in South America, they don't have any hypertension, like none, zero, okay? So just more proof we're designed to eat a plant-based diet. I hope that was helpful. I thought it was especially interesting that it's a kidney. And what I'm saying by this is it reminds me of an old sermon. I remember when I was riding to a wrestling tournament, the guy loaned me his car and his CD player, or the audio tapes that were back in those days. Brad Hightower was the guy. And there was a sermon on there that said, you don't break the law breaks you. If you jump out of a window, the law of gravity will break you. And so what I'm trying to say is you can't change the fact that the body wants a high potassium diet and a low sodium diet, and it wants the magnesium, it wants the plant nitrates, and it wants the plant fiber to make all your bodily systems function. They're designed to run on that. Your gut is designed to run on fiber. There is no fiber in meat. There's very little fiber in processed food. Processed food wasn't even around before the last 100 years, for the most part. So what I'm saying is, it's obvious. This is what we're designed to run on. These starches and these fruits and these vegetables. It's obvious. I could care less. I would eat meat if it would make me healthy, if it would make me 18 years old again. I would do it, but it doesn't. It makes you fat and sick and stupid. So anyways, I thought that was interesting.